All right. In the last class, we studied the introduction of trigonometry. Gautam, have you remembered the values till 90 degree?
Yes, sir.
Okay. And Abdul? All right. So we know that trigonometry is the measurement of angles, right? We use mostly angles and ratios. Write down measurement of angles. All right. Till now we are dealing in degrees, right? But degrees has also many categories. Like suppose you are trying to measure length. All right. You can use 1 kilometer, 1,000 meter, or in centimeters, millimeters, and so on. Right? Same distance can be calculated in many units. The same way, angles can be measured in degrees or radians. All right. So first, let's deal with degrees. We know that one right angle is equals to how many degrees, Gautam? One right angle,
Sir, 90 degree.
90 degree. Absolutely right. All right. This is the standard division. All right. Whoever measured these degrees, this is x-axis, this is y-axis. He divided this angle into 90 equal divisions, right? Each one is a degree. 1 degree is equals to 60 minutes. All right. Or 60 one apostrophe. All right. 60. If you write like this is 60 minutes. What that means is, see, this right angle was divided into 90 equal divisions. If you take each division, each degree, then they are further divided into 60 parts, which is called a minute. So each degree is divided into 60 equal parts, and they are called minutes. We write it as this 61 dash. Then if you take each minute, that is divided into 60 seconds. 60 double dash. All right. Why this 90, 60, 60? Because whoever invented this, he used this thing. So we cannot change that. All right. Write it down. Each degree is 60 minutes. Each minute is 60 seconds. We write it like this. All right. Note it down. All right. Now you can see that minutes and seconds are smaller quantities than degrees, right? Because they are divided into many further quantities, just like kilometer, then meter, then centimeter, and so on, right? So if they ask you convert this, write 90 minutes in degrees. So how to solve? Basic conversion method. We know that 1 minute is, or 60 minute is 1 degree. So 1 minute will be 1 upon 60 degrees, right? Don't use this bracket. Just for understanding, I'm using that. So 1 minute is this much degree. So 90 minutes will be 1 upon 60 into 90 degrees. And this is 1.5 degrees. Clear? Basic conversion method, right? If 10 pens are 20 rupees, then 1 pen like that. Gautam, Abdul, clear?
Yes, sir.
Okay. Note it down and solve this question. Write 50 degree in minutes. All right. Try this one. I'll give you a few minutes. All right. So 1 degree is 60 minutes. So 50 degree will be 50 into 60. Is that 300 or 3000? 3000 minutes. All right, Gautam. You missed a zero there. Gautam, is it clear?
Yes, sir.
Okay. Abdul. Arsalan, are we clear? I don't know when you came into the class. Okay. So basically, 1 degree is 60 minutes. 1 minute is 60 seconds. All right. This is angle measurement, not time. All right. Don't forget like that. And 60 minutes we write this. 60 seconds we write this. Next question. I'll note it down first. Then all right. Right. 30.54 degrees in degrees, minutes, and seconds. I want to remove this decimals. All right. So convert this into minutes, seconds, degree, minutes, and seconds. Try this one out.
Sir, this is already in degrees.
Yes, Gautam, but see, I don't want this 0.54 degree. This is 30 degree plus 0.54 degree, right? So this I don't want to change, but this I want to convert in minutes and seconds. All right, I don't want to write in decimals. Clear?
Sir, we have to convert the whole value into minutes and seconds.
No, only this decimal part. See, if they are saying degree, minutes and seconds, that means they don't want to use decimal points. So this you can write 30 degree plus 0.54 degree. This is okay. There is no decimal points here. This you can convert in minutes, and if the decimal exists again, then you can convert in seconds. Clear?
Yes, sir.
Okay. Have you solved it, Gautam, Arsalan?
Sir, I got 1944 seconds.
All right, let's see. So this is 30 degree, and I can write this as 0.54 degrees. If I have to convert this, this will be 30 degrees, 0.54 into 60 minutes, right? To
So I
convert the
didn't
degree into,
uh, calculate 30 degree. I did 0.54 alone.
sorry,
I didn't include 30 degree. I did 0.54 alone.
yeah, me too. See, I didn't change 30 degree, only this one. Okay, you can also keep it out, but I am writing because this is a whole quantity, right? You can leave that, write that in the later stage, but if you write it like this, that is better, right? Because this is a whole number, you cannot separate. So this degree is converted into minutes. I can multiply 60, and this is 30 degree into, how much is this, Gautam?
So
Did you multiply?
32.4.
32.4. So now we have 30 degree and this much minutes, but there is also a decimal here. So I can write this 30 degree, 32 minutes and 0.4 minutes. Now I can change this into seconds. This is 32 degree, 30 degree, 32 minutes, 0.4 into 60 seconds, right? So this is 30 degree, 32 minutes, and this is 24 seconds. This is the answer. Gautam, is it clear?
Yes, sir.
Okay. Arsalan, Abdul, all right. Note it down. Now write radian measurement. All right. First write the definition. Radian measurement. The angle subtended by an arc of a circle whose length is equal to the radius of the circle at the center of the circle is called a radian. In this system, the unit of measurement is radian. In radian, we denote it as C. All right. Note it down first, then I'll explain. All right, note it down. Gautam, Arsalan, Abdul. All right. See, in degree measurements, what we do is we took a right angle, we divided it into 90 parts, right? Each one was a degree. In here, what we do is we draw a circle, any circle we draw. All right. If the radius is r, you stand here, walk in the perimeter of the circle to a length, how much? R. And the angle subtended by that arc at the center, this one, is 1 radian. Is it clear? Is it clear what I said? Gautam, Arsalan, Abdul.
Yes, sir.
So if you walk to 2r, then that will be 2 radian. And so on. So why this unit? All right. Why measured like this? Because no matter what circle you take, the angle will be same if they are concentric. Okay, give me a minute. If they are concentric, we can see clearly that can you guys see one note? Give me a minute only, 1 minute only. All right. So to find 1 radian, what we do is you take a circle, you walk a distance r, the angle subtended at the center is 1 radian. All right. Okay. So how much is 1 radian in degrees? Right? We need one conversion formula to change. Right? We know 1 kilometer is 1000 meters. So we interchange between them. If we don't have any formula for that, that would be troublesome. So how to find that out? In class 9th, you have studied that the angle measured at the center is directly proportional to the length of arc. Right, Gautam? The longer you walk, the larger the arc, the larger the angle subtended at the center, right?
Yes, sir.
So we can write theta is directly proportional to the length of arc, or we can say theta is equals to KL. K is a proportionality constant, any constant. So I can say that theta 1 is equals to K times L1, or theta 2 is equals to K times L2, or I can say that theta 1 upon theta 2 is equals to L1 upon L2. This is basic proportionality. In class 8th, you have studied this, right? No doubts here?
No, sir.
Okay. So this we already know. Now, if I draw a circle and take two arcs, one is at a right angle and other is at this much. All right. So if this is right angle, then this length, Gautam, can you tell me how much this arc will be?
So 45.
45. No, I am saying what will be the length of arc AB? This one. If the radius is r.
Sir, R square.
How do you calculate r square? See, for a whole circle, the perimeter is 2 pi r, right? For 360 degrees, you get 2 pi r. For 90 degrees, you will get 2 pi r by 4, right? You walk 1/4 of the perimeter. So pi r by 2. Is it clear?
Yes, sir.
Okay, Arsalan. And Abdul. All right. So theta 1, let's take this 90 degrees. All right, this is theta 1, AOB. And theta 2, I'll take in radians, 1 radian, right? Because if you walk r length, then the angle subtended is 1 radian. So L1, the arc is pi r by 2. L2, this is r. So r and r is cancelled. 1 radian, if you cross multiply, we get 180 upon pi degrees. This is the formula to convert things. Is it clear? Is it clear?
Yes, sir.
Okay, Arsalan. Okay. So you can also find 1 degree here. If 1 radian is equals to 180 upon pi degrees, then 1 degree will be pi upon 180 radian, cross multiplying. These two formulas are used to convert things to radian into degrees and degrees into radians. All right, note it down. I'll give you 2 minutes. And if you put the value of pi here, 22 by 7, then 1 radian comes close to 57.3 degrees. All right, the specific value, you never have to use this, just for knowledge, that 1 radian is 57 degrees. All right, so if you take 3 radian only, then you get close to 180 degrees. So radian is a big unit of measurement, right? 30 degrees, 45 degrees, that you will come as like decimal points in radians. Note it down. One thing here we can write also that pi radian is 180 degrees. All right, write down important angles in radian. All right, 90 degree. Please convert this into radians and keep that in pi only. All right, don't put the values of pi, leave it in pi also. All right, Convert this. I'll give you 2 minutes. Gautam, Arsalan, Abdul. See how to solve this. We have 180 degree is pi radian. So 1 degree is pi upon 180 radian. So 90 degree will be pi upon 190 into 90. So this is 2. So pi by 2 radian. Is it clear? Very easy unitary method. Gautam, Arsalan, Abdul.
Yes, sir.
Okay. So whenever you see pi by 2, that is in radian, and the value is 90 degree, right? Pi by 2 means 90 degree. Convert this 60 degree. All right, I'll give you a few minutes. Gautam, Arsalan, have you solved this 60 degrees in radians?
Yes, sir.
How much?
Pi by 3.
Pi by 3, absolutely right. So how to change this? 1 degree is pi upon 180 radian. So 6 degree will be pi upon 180 into 60. So this is pi by 3 radian. All right. Convert this 45 degree. So now on, from now on, whenever you see pi by 3, that means 60 degrees. Okay. 45 degree. Okay. How much is it? Bottom
Sir, pi by 4.
pi by 4. So this is pi by 4 radian. Few more degrees. Convert 30 degree, 180 degree, and 360 degree. All right. I'll give you 2 minutes. Send the answers in chat. All right. Gautam, Arsalan, Abdul. Right. Yeah. So this is pi by 6. This is pi radian. This is 2 pi radian. Absolutely. So from now on, whenever you see pi by 4, pi by 6, pi, 2 pi, you have to deal with this. All right. From now on, angles don't or will not be in degrees. But write down length of arc theorem. This is clear, right? Gautam, Arsalan, Abdul. No doubts here. length of arc theorem. Alright, if you have to find the length of any random arc, alright, this is theta c. You have to find the length of AB. This length BC is R, and this is 1 radian, right? According to the definition. So I can say angle AOB upon angle BOC is equals to AB, right? Arc length upon CB. Is it clear? Or take that length as L. This is L upon R. Can I write it like this or not? Gautam, Aslan. All right. This angle and this length, this angle and then. So this angle is theta c, and this is 1 radian. This is L upon R. So we can say L is equals to R theta. All right, where theta is the angle in radians. Note it down. So any length of arc you have to find, just multiply the radius times the angle measured by that arc at the center in radians, not degrees. All right, don't forget that this is in radians. Very important. If you put 60 degrees, this will be very wrong. You have to put pi by 3. All right, note it down. The definition also, the angle subtended by an arc of length L at the center of a circle of radius r is given by theta is equals to L upon R, where theta is in radians. All right, note it down. Clear about this? Gautam, Arslan, Abdul?
Yes, sir.
Okay, write down the question. Find in degrees the angle subtended at the center of a circle of diameter 50 centimeter by an arc of length 11 centimeter. Alright, try to solve this one. You have to find the angle subtended by the arc at center. All right, have you solved this? Gautam, Arslan, Abdul, Gautam.
No, sir.
This is a circle. All right, the angle subtended by the this diameter is 50 centimeter. That means radius is 25. By an arc of length 11 centimeter. So this angle you have to find. We know that L is equals to R theta, right? So theta will be L upon R. L is 11 and R is 25. This comes in radians. We find in degrees. So convert this radians into degree, and the answer is yours. 11 upon 25 radian. So we know that pi radian is 180 degrees. 1 radian will be 180 upon pi. So this will be multiply this with 180 into pi. Pi value is 22 upon 7. This 7 is here. So this is 2. This is 90. Rest of the calculation you can do it. All right, easy. Gautam, Arsalan, Abdul.
Yes, sir.
Okay, Arsalan. All right. The one thing you need to remember is here theta is always in radian. All right. Next question. Write down. Find the length of an arc of a circle of radius 5 centimeter, subtending a central angle measuring 15 degree. All right, try to solve this. I'll give you a few minutes. Here you have to find the length of arc. That means L. All right. solve this? Gautam, Arslan?
Yes, sir.
Okay. So first we have to convert this 15 degree into radians. So how to convert this? Pi into 180 into 15 radians. Put this value. So L is R theta. So R is 5 and theta is this much radian. And 15 upon 180. Whatever the answer is, the answer to L. Right? Clear? Arsalan, Gautam.
Yes, sir.
Okay. Another question. A horse is tied to a post by a rope. If the horse moves along a circular path, always keeping the rope tight and describes 80 meters, or what, tied at 88 meters, 88 meters when it has traced out 72 degrees at the center. Find the length of rope. All right. Few minutes for this. All right. Have you solved this? Gautam, Arsalan, Abdul? Gautam,
No, sir.
they are saying there is a post, all right, and a horse is tied to a rope and he is moving in a circular path. All right, that's not proper circle, but imagine like that. So you have to suppose this is R and he has moved at a distance of 88 meters and the angle traced out is 72 degrees. You have to find R. So first you have to convert this 72 degrees into radians. So 72 degrees is pi upon 180 to 72 radians, right? So this is 18 and it is 4. So 2 pi upon 5 radian. We know that L is equals to R theta. So L is 88. R we have to find. Theta is 2 pi upon 5. And the value of pi is 22 by 7. 88 is equals to R into 2 upon 5 into 22 by 7. So this is 44 2s are. So R is 70. Clear? This one formula is used, nothing else. Clear, Gautam, Arsalan, Abdul?
Yes, sir.
Okay, note it down. All right. See, in class 10th, you studied all the values till 90 degree. But in 12th, 11th, 12th, that value is infinite, right? Suppose you move from here to here. So you're moving 90 degrees. But if you move from here to here, that means this is 180 degree. Here is 270 degrees. And so on. Total is 360 degrees. Also, you can move ahead plus 90, plus 90, plus 90, and so on. So this circular path keeps going on and the angles keep increasing. All right. So write down sine of trigonometric functions in first quadrant. All right. We have to know which value is negative or positive in which quadrant, right? We have 4 quadrants. This is first, this is second, this is third, and this is fourth. So in the first quadrant, x is positive and y is positive. If this is the angle theta and this is y and this is x, and this is suppose r, x square plus y square. All right, x square plus y square. We know that sine theta will be y upon r. Is it not clear? Gautam, Arsalan, Abdul, sine theta is perpendicular upon hypotenuse. So if this is theta, then this is perpendicular and this is hypotenuse. So y upon r. So y is positive and r is positive. So sine is positive in the first quadrant. Cos theta x upon r. X is positive, r is positive, so both positive. cosec theta, inverse of sin theta. So this is also positive, r upon y. Sec theta, inverse of cos theta, r upon x, also positive. Tan theta, division of both sine and cos, that is y upon x. This is also positive. Cot theta, inverse of this x upon y. So this is also positive. So what this means is, if any angle is between 0 to 90 degree, then all the functions sin theta, cos theta, cosec, sec, tan, cot, all of them will give positive values, right? In class 10th you studied all the values, all of them were positive. Is it clear, Gautam, Arsalan, Abdul?
Yes, sir.
Okay, note it down. Note it down. All right. In the second quadrant, this is theta, this is r, y, and x. In second quadrant, x is negative, y is positive, sin theta is y upon r. So this is positive. Cos theta is, Gautam, what will be cos theta here?
So x by r.
X by r. And x is negative, r is positive. So cos will be negative in the second quadrant, right? Cosec theta, r by y. This is positive. Sec theta, r by x. This is also negative. Tan theta. Tan theta is y upon x. Y is positive, yet x is negative. So this is negative. Cot theta will be x upon y, same, negative. All right. Note it down. This is clear, right? So any angle between 90 to 180. If I give you sine 135, cos 120. So these angles are between 90 to 180. They will give you respective values, positive and negative on. All right. Is it clear where we are going to apply this? Gautam, Arsalan, Abdul?
Yes, sir.
Okay, note it down. All right. In the third quadrant, this is the diagram. This is y, this is x. r. So in third quadrant, x is negative and y is also negative. So sine theta will be y by r. So this is negative. Cos theta will be x by r. This is also negative. Sec cosec theta r by y negative. Sec theta r by x negative. Tan theta y upon x. So negative upon negative, that is positive. Cot theta will also be positive, x upon y, that is positive. So in the third quadrant, that means 180 to 270 degrees, everything will be negative except tan theta and cot theta. Note it down. All right, note it down. In the fourth quadrant, this is the diagram. This is y, this is x, this is theta, this is r. So sine theta is y upon r. Here x is positive, y is negative. So this is negative. Cos theta is x upon r. So this is positive. Cosec theta is negative. Sec theta is positive. Tan theta, that is y upon x. This is negative. Cot theta is x upon y. This is also negative. So from 270 to 360 degrees, everything is negative except cos theta and sec theta. All right, note it down. All right, note it down. So how to remember these things? To remember this thing, there is a basic trick. Draw this quadrant, write A, S, T, C. All right, say it again and again. ASTC, ESTC. All right, you have to remember this, otherwise it's going to be an issue. A for all, S for sine, T for tan, C for cos. All positive, sine positive, so cosec is also positive. Tan positive, that means cot is also positive. Cos positive means sec is also positive. Here everything is positive. Here only sine theta and cosec theta is positive. In third quadrant, only tan theta and cot theta is positive. Fourth quadrant, cos theta and sec theta is positive. Is it clear? Remember this trick, ASTC. Gautam?
Yes, sir.
Okay, remember, clear this? This is clear, absolutely clear? Note
Sir, can you explain once more?
once more, all right. See, in the first quadrant, you write A, second quadrant S, third quadrant T, fourth quadrant C. A means all means all positive. That means if you take any angle from 0 to 90, every value will be positive. All the values, sine of that angle, tan of that angle, cos of that angle, everything will be positive. But if you take second quadrant from 0 to 90 to 180, any angle between 90 degree to 180 degree, then only sine of that angle and cosec of that angle will be positive. If you try to find cos of that angle, the value will be negative. Is it clear till now?
Yes, sir.
So in the third quadrant, that means any angle between 180 degree to 270 degrees, everything will be negative except tangent and cotangent, tan and cot of that angle. These values will give positive value. In the fourth quadrant, that means 270 degree to 360 degrees, cos of that angle and sec of that angle will be positive. Everything else will be negative. Try to find sine 300 degree. 300 comes in fourth quadrant, right, Gautam?
Yes, sir.
So this value will be negative. We don't know what value will be exactly, but we know that this will be negative value. All right, we are going to learn how to find the exact values, but just the sign, all right, will be negative. Clear? Note it down. All right, write down. angle measured in anti-clockwise direction is positive. Angle measured in clockwise direction is negative. What this means is, if you calculate the angles like this in this direction, then we'll take positive, like this is 30 degree. But if you calculate it in this way, then this is minus 30 degree. All right, if this is theta, then this is minus theta. All right, so from here what we get is sine of minus theta is equals to minus sine theta. Always sine of negative angle, you can take the negative outside of sine. Cos of minus theta, cos eats the negative sign, so it is only cos theta. Cosec minus theta, it is inverse of sine, so minus cosec theta. Sec of minus theta, sec theta, inverse of cos. Tan of minus theta, minus tan theta. Cot of minus theta, minus cot theta. All right, everyone except cos and sec take the negative sign, put it outside, but cos and sec eat that negative sign. What this means is, if you have to calculate sine 150 degree, minus 150 degree suppose, then this is equals to minus sine of 150 degree. But if you have cos of minus 270 degree, then this is equals to cos of 270 degree. Cos eats the negative sign. Is it clear, Gautam?
Yes, sir.
Okay, note it down. All right, write down. Gautam, this is clear, right?
Yes, sir.
Okay, trigonometric ratios for angle greater than 90 degree. All right, till now we only know the values till 90 degree. How to find the values which are greater than 90 degree? All right, so if this is a trigonometric function of any kind, all right, sine, cos, I'm generalizing it with t. If this is 90 into n plus minus theta, write it down, I'll explain. If this is t means any function, trigonometric function, if this is the way any angle is written, right, 90 into n plus minus theta. All right, case 1, if n is even, then sine will remain sine, cos will remain cos, tan will remain tan. Means all functions will remain same. All right, I'm writing these three. You can check for the inverse also. All right, write for the inverse also. Cosec will remain cosec and so on. All right. Case 2, if n is odd, then what happens? If n is odd, then sine will become cos and cos will become sine. Tan will become cot and cot will become tan. Sec will become cosec and cosec will become sec. Write it down. I'll explain how to solve all it. Just write it down. Gautam, noted it down.
Yes, sir.
Okay. So how to apply this? Write down a question, sine 120 degree. How to find the value of sine 120? I can write this as sine 90 plus 30, right? Or sine 90 into 1 plus 30. Is that right, Gautam? Gautam, is it clear?
Yes, sir.
So if I compare this with that equation, t 90 into n plus theta plus minus theta. Here the value of n is 1 and theta is 30 degree. So n is odd, right? N is odd. For case 2, n is odd, then sine becomes cos. So here sine will become cos, and this will vanish. This will be cos theta, that is cos 30. Is it clear, Gautam?
Yes, sir.
But this is two step. This is the first step. The second step is you have to check for the sign also, for the original value. This is sine 120. So 120 comes in the second quadrant, and in second quadrant sine is positive, so this will have positive sign. So the value of this sine 120 is cos 30. And Gautam, what is cos 30? Do you remember the value for cos 30?
Sir, root 3 by 2.
Root 3 by 2. So this is the value of sine 120. Clear?
Yes, sir.
Is it? All right. Note it down. All right. So this is all for today's class. In the next class, we'll move ahead with this, solve different questions. All right. Please revise this. Otherwise, we'll forget everything. All right, Gautam, Abdul, you have to revise. All right.
Yes, sir.
Okay. See you in the next class. Take care.